Yeah, for the one forgetting. What time tomorrow we have no class. Tomorrow no class. What time? What time? I don't know. We did one that over. Yeah, they want me. But we found out what she said. Then we decided. Yeah, it depends on them and the next day. Thursday, I'll be there in spirit.
Okay. So your CL4, your CL3, CL4 will be in your test tube. Okay. So for those latecomers, you ask your colleagues, you ask your classmate lah. The scope will be coming up. So your final exam will be question 1 CL1, question 2 CL2, question 3 will be CL3, question 4 and 5 will be CL4. Okay. Okay. So suppose you have an electrical electronic material for this module, but we don't have enough time to cover this one, so we will stop at composite, polymer. Okay, so for polymer, we are focused on hydrocarbon only. Hydrocarbon, which is your petroleum, because we are a petroleum produced country, so we focus heavily on this chapter. Hydrocarbon, the name itself, it consists of C and H, right? And the bonding is covalent. C and H, the bonding is covalent bonding. So this is when you draw the Bohr's models. C will be at the center, and 4 hydrogen atoms, ion, combined with the carbon ion to form covalent bonding. Okay, so 2 electron, 1 pair of electron will be represented by single stroke. Right, this is structural formula. Okay, structural formula. Don't confuse with configuration formula, the SPDFs, right? So don't confuse this one during final exam. So in chemistry, when they use the word saturated hydrocarbon, it means only have single bond, means single dash there. This one is double covalent bond, which is carbon-carbon with the double bond in the middle. So this one is ethylene, C2H4, and you have triple bonds for hydrocarbon. So just now is single bond. This one is double bond, and this one is triple bond. Okay. So double bond example is ethylene, triple bond is ethylene. They are unsaturated. Okay, they are unsaturated. So if they are more than one bonding, one covalent bond, they are become unsaturated. Okay. So this one, a word called isomerism. They have the same composition but different atomic arrangement. They call isomerism. For example, butane. This is a normal butane structure, 4 carbon and surrounded by hydrogen. But this is isobutane, same 4 carbon, but the arrangement is different. So these are the composition for hydrocarbon: methane, CH4, ethane, C2H2, propane, and so on. Okay, so in your SPM chemistry, you already know the general equation for hydrocarbon, right? CnH N plus 2. Okay, and these are the structure and boiling point. So one need to highlight here is as you increase the molecular weight, your temperature, boiling temperature increase, because you need more energy to break the bond. Okay, the rest is the same, right? The rest is the same. So for example, alcohol, you have a OH, oxygen there, and in the exam you will see something like this, right? If you The exam will ask you to restructure or draw the structure for the hydrocarbon. So if you are building this one, or your question give you this symbol, you need to convert this one into this one, right? So this one will be given in the question or in the appendix lah, at least. So if you see a ring, then it is you need to convert the ring into 6 carbon and 1, 2, 3, 4, 5, 5 hydrogen. So in our industry, we have 2 types of polymer, plastic and elastomer. The differences is plastics, they are converted into, they have 2, thermoplastic and thermosetting. Elastomer, they have, basically they are rubber, right? So these are the 2 lah, polymetrics, plastic and elastomer, or plastic or rubber. Okay, thermoplastic, this one you read. Thermoplastic and thermosetting, they have their own way of characteristics. Thermoplastic, you require heat and can be reheat. Thermosetting, they are permanently shaped like Lego. You cannot, even you once you burn it, you will melt. Cannot be remelt or reformed into another shape, but degrade and decompose when you heat. Okay, so this is the difference between thermoplastic and thermosetting. Okay. Okay, then this one you learn in your SPM or secondary school standardized exam. You know, polymer consists of many monomer. Okay, then monomer, they form a long chain, they become polymer. Okay, so the next one is a single bond. Double bond is how you convert the dot here, the electrovalent dot, into the stroke here. Okay. So this one you read lah. This one quite direct. So is the next one is to tell you how the chemical reaction happen. So when this double bond break up, this one break up, it will open to another side. This one open to another side. So when this one break, it can handle 2 more hydrogen or 2 more negative charge. Okay, because it's open up this one. This dot move to here. This dot move to here. So any molecule that have group 7. Group 7 means it's lack of 1 electron outside. It can park inside here. Okay. So it depends on what element that going to attach here. It's like a space station, International Space Station, how you dock the things. Okay. So this one is called half covalent bond because it's only have 1 electron outside here. Okay. Okay. Then next we're going to recall what is polymerization, how you polymerize. So you put in a catalyst R dot plus the polymer. So this one going to break, this double bond break, then join with the catalyst. Then there's a 1 extra dot here. So you're going to catch another chain. So let's say this one have 2. So you will catch another and join together. So it's going to be very, very long chain. Okay, it's like a train combined together. The one that you see here is ethylene, right? So it can be combined a very, very long chain. Okay, so this is the schematic presentation. If you have a 3D model, then it's look like that. And you have a repeated unit. This is a repeated unit. So when you have repeated unit, you can represent this one by a bracket and put a small n below. Okay, it's chemically you write. Okay, so this is how you write a chemical reaction in chemistry. So this is monomer ethylene with the N outside. You through catalyst or heating, polymerization happen. So this is a monomer. You just put a bracket with a dash, and then put an N here. This is a poly something. It depends on the monomer that on the left hand side. Okay. Now there are other way of writing this one. You can either convert the big bracket into a round bracket, or you can write CH2 combined with the chemical, right? You can write in this form. These are the three forms that we accept as answer in the final exam. Okay. Now, if we look at ethylene to polymerization, if the question asks you if a particular type of polyethylene have a molecular mass of 150,000 gram per mole, what is the degree of polymerization? So you calculate degree of polymerization. Today you have your first equation for today. Degree of polymerization is that you take molecular mass of polymer divided by the monomer mass. Means how many N? Degree of polymerization is the N here. Okay, it's the N here. So if you are given this molecular mass of the polyethylene of this one, you need to calculate polyethylene, this one, ethylene monomer, single unit, how many? How many gram per mole? Okay, so you already know how to calculate, right? If you're given the periodic table. So of course, carbon, you know, is 12. Hydrogen is 1. So how many? 12, 16. Correct? 16 gram per mole. Sorry. 28. 12, correct. 24. So the monomer is 28. So you take 28. You can divide the 150,000 gram per mole. So polymerization, degree of polymerization is 5,000 something. Okay, so this is the way you calculate, very simple formula. There's nothing differentiation or something. Right, so this is a very simple question for polymer. Okay, chain reaction, you have 3 steps here. Okay, 3 steps. One is initiate, propagate, terminate, means start, happening, and end. Okay, so if the question asks you what are the chain polymerization steps, you need to mention these 3 and then explain what happened in the initialization, what happened in propagation, what happened in termination. Okay. So initialization, you need to break. For example, polymerization of ethylene, consider use of peroxide as catalyst. So peroxide, H2O2, it look like this. When you heat it up, you break into HO and OH. Okay. Then you write in the hydrogen peroxide, these 2 dot become 1 dash, 2 dot become 1 dash, 2 dot become 1 dash. You heat it up, become 2 HO with the free electron here. There's 1 extra electron here. So this is called free radical. And organic peroxide, it depends on what you do. For example, you replace nitrogen peroxide. This one is hydrogen, so you use H. But in general formula, you replace the R with the name of the peroxide. For example, nitrogen, then you change the R into N. Natrium peroxide, natrium Na, so become Na, for example. Okay. So what happened in initial, you take a free radical plus the ethylene. So again, ethylene, it break into 2 single bond here. Then this one dot join here. It become RO dash CCHHH, but one free electron. So this is the starting stage, initialization, where you add catalyst. Okay, this is the general equation, R dash O dot plus, and then it depends on what ethylene you have or hydrocarbon you have. You'll be given a table, so you just copy from the table, put inside the equation, and then you write the remaining things. You'll be given a table of all kinds of hydrocarbon. So the question will mention something from the table. You just pick from the table and complete this equation, this chemical reaction. Okay. Careless mistake is this one. You will be forget to put this small dot at the back. Remember to put a small dot at the back. Okay, we have done with the initialization, then it starts to propagate. Propagate means it continue the process. It combine all the small chain, right? So this one is a small dot plus the complete hydrocarbon. Then it continue with the long chain. Okay, it means it break this double bond into single bond. Then it become a long train like that. Okay. So this is the equation we expected from your answer. So after propagate, how it terminate? When it terminate, you need to remove the free radical, the small dot there, or when two chain combine. Okay. So how does this end? So this is the free radical with the small dot plus free radical with the small dot. So you have a R dash means the second hydrocarbon. It combine, this one will put it here. So it will balance the whole equation. What's the difference? Is that you remove this small dot, this one combined with this one. Means this one you move to the back, this one you will open up, then this one join here, right? Or you can say this one small dot combined with that dot. Okay, you'll be seeing this table in the final exam. Okay, so just now the example is the first one. So if the question mention polytefluoroethylene ethylene FE, he asks you to explain the process from initialization to termination. So you start with the equation R dot plus this one, and then you try to break. Understand? So this is a very easy question because all the information given, you just need to memorize these steps. All these steps, just substitute this one. Substitute this formula. Okay. Just change this. Just now you see it's this one. You just substitute this one with, let's say the question asks you PTFE. Substitute this one inside there. Okay. Of course, final exam won't be that easy. You will see ring here. You'll see ring. Okay. So polymerization. Let's see this short video. Let's see if the network okay or not.
The raw material used in the process
So
is
just show you
ethylene,
how the
which is the
chain
monomer in this
broken.
case.
Double bond.
While
becomes single
monomer
bond.
means one part,
So
polymer
this is
means
ethylene, the
many
most
parts.
simple
So
hydrocarbon
polyethylene basically means
structure.
many ethylene parts. But how do we get from one part to many parts?
You see the
It
R means
actually
catalyst.
takes 3 steps. The first step in the polymerization process is the initiation. When heated, the organic
Mineralization,
peroxide
heat.
breaks apart in 2 radicals.
You break the bond.
These radicals start the reaction
Then
with
you find
ethylene.
one dot.
One free radical
hole here,
opens the double
something
bond
like
of an ethylene molecule and forms a new radical.
Yeah, dot is the single
Then
bond.
this new radical opens another ethylene monomer, and this process continues, making the actual polymer. This second step is called the propagation.
You continue to join the
Now there's
string
only one step to go to turn a
until
monomer
termination.
into a
Termination
polymer,
means
the
another side is
termination.
out. And as long as it's
The
stable,
polymerization
when you
reaction
put
stops
R,
once the
R
last
prime,
radical
one
on
side
one
is
polymer
without the
chain
comma,
meets another
one side is
chain
with
with a
comma.
free radical.
So this
Then
is
they combine,
termination.
and the polyethylene is finished.
Okay, so this is how we do. Okay, next is this formula. It asks you to find average molecular weight. Is simple. You take fraction of molecular weight equal to the small molecular weight. Okay, it's like finding the average value. Okay, let's see. See, this one is you can use the degree of polymerization just now. Okay, I'll give you one example. So let's say you're given this table. So if you are given a thermoplastic material with a mean molecular weight fraction Fi for the molecular weight range. So means this one, if you add all this one, you get 1. Means 100%. This one 11%, 17%, 26%, 22% have this range of molecular weight. All right, you add all this, you get 1. 1 year, I come out with this in final exam. I purposely put this one as 95%. You have to follow 95%. Okay, okay, I show you how lah. So, but if you assume 100% is wrong, time I purposely change the number here, and I think 80% of the class gone this question, because at almost 80% they assume is 100%. Okay, so how you do? You take the mean of the range. For example, 5,000 to 10,000. What is the mean? What is the mean? 7,500 lah. This one we find the mean. After you find the mean, you copy the fraction, 11%, 70%, all this you add lah. So this one normally will be 100%, but be careful lah. Sometimes I will be tricky over here. It will not be 100%. So this one, after that, you take this one, multiply this one, you get one number. Take this one, multiply this one, you get one number. You add the total number here. Then you take this one, multiply this one. You just take the formula like that. Okay, just take the total number divided by this one. Okay, so don't assume always 100%. This one, careless mistake. Don't assume this 100%. Sometimes, or already I try one time, this one you add up 0.95. So you need to divide by 0.95. You add up first. Okay, don't always assume it's 1. Okay, so this is the molecular weight for this polymer, for these thermoplastics. Because in the this one, how you get this one is from the processing machine. Let's say you don't know what is the molecular weight, you put inside the powder, then the machine will calculate for you. Okay. So this is another example. Tutorial question, this one your homework. So if you understand example 1, this one you should able to do. So this one asks you to number average molecular weight, degree of polymerization, weight average molecular weight. So this one, the first one, if you're given the xi, you're given the xi. Another one is weight fraction. Weight fraction. So what is the difference between fraction of total number of chain and fraction of molecule within the interval? Okay. Anyway, the equation is still the same. You find the mean. You find the mean. Take the mean, multiply by the whatever number you see here. Either it's xi, wi, or fi. You need all kind of question. You see the range one, you find the mean first. Take the mean, multiply by the fraction number. you get one number. Total the number, take the number divided by the total number of this one. Okay, it's the same steps lah. You see, okay. Again, find the mean. It's a very simple question. So don't, every time you see polymer question, don't skip. Sometimes polymer question is more easier than the composite question. Okay, so take this one, multiply by this one, you get this one. Then, okay, this one, for the xi, you don't need to divide already. For, yeah, you just total the things. Okay, xi is what? Xi is total number of chain. Okay, but anyway, it's good to check. Check the total first. If this one not 1, take this one divided by this one, you get the number. Take note. It's not always 100%. Same, the second one. You want to find the degree of polymerization. So this is the value you get. You need to calculate the monomer molecular weight. So this one already calculate 28, right? 12 plus 4. Again, this one is a bit different. This one is polyvinyl chloride. Is Cl. Is Cl. You need to refer to the periodic table, find what is Cl molecular weight. This one. Don't assume always you have hydrogen at a four corner. Okay. So you take 21150 divided by 62 is degree of polymerization. The next one, weight average molecular weight, same. You take the mean, multiply by the weight. Okay. You get one number. Again, check whether this one is 100%. If 1, then 1. This one divided by 1. If this one 95, this one divided by 95.95. Okay. Okay, this one you functional or monomer. Functionality of monomer. Okay, so this is just that how when you break the bond, how many you can join. For example, this one bifunctional means they have double bond. This one, when you see this one OH something, if a triple bond, triple bond. For example, C6H is a triple bond things, so you will see is a trifunctional. Basically, you see how many bonding you have inside there. Okay, so this one you read. We are clear with the normal hydrocarbon ethylene just now. We go into PVC because we use a lot of PVC in daily life. So PVC is you combine ethylene with another items. With this, we replace the one of the H with R here. Right? We replace with the R here. We call it Vilene polymer. Just now, previously is H. We have 4H, now we have R1. Again, you will see this one in your appendix. In the table just now, you already see all these things. Okay. Oh, even the LCD is shaking. Okay, so this is also the same. Polymerization happens when you break the double bond or double bond, triple bond into single bond. And there's N there. So N is the degree of polymerization. How you find the N? You take the general molecular weight divided by the monomer weight. You can find the N. Okay. So the rest is same. This one you read. Okay. So Homopolymer, homo means same, like Homo sapien is human. So homo is it means same, so they are repeating same. A. Right, means copolymer. Copolymer, it can be A, B, C, D like that. So it can be, you see the color changing, dark blue, light blue, double dark blue, and so on. So this is non-consistent. Then this one, another one, AB, AB, AB like that. It become called polymer lah. If it's all same color, then it's a homopolymer. So you have different. They have also have chain. This is random, alternate, and so on. Okay, block. Copolymer means one block, AAA, then BBB. Graph polymer, there's a diversion or intersect. Okay. This one is another illustration. This one you read. Okay. Now, this is example 2. Example 2, it gives you copolymer consists of 15% PVA, polyacetate, and 85% PVC. Determine the mole fraction of each component. It asks you to find mole fraction, means how many mole, so and so. So you're given the two formula, molecular structure like this. So the A is polyacetate with this one. B is PVC lah. This is PVC. This one is PVC. So it's a combination between these two, 50% of this one, 85% of this one. Asks you to find mole. So again, it's always in chemistry, we have one constant mass. In this case, we assume you have 100 gram of copolymer. So then you have 50 gram of PVA, 85 gram of PVC. Okay. You convert the percentage into gram. Then you determine number of mole of each component. You can find, right, molecular weight here from the periodic table. You add all the element here. Okay. So for polyvalent acetate, you have all this, right? You have 4C. 1C is 12. 1, 2, 3, 4. So 4C, 6H, 1, 2, 3. And then this one 3 got 6. So each hydrogen is 1. And then O, oxygen is 16. You have 2O here. So 2O add up is 86 gram per mole for one monomer. You do the same for this one, PVC. Right? So for polyvalent acetate, you have 0.174 mole. And you calculate for PVC is 62.5 gram per mole for this one. So you take 85 divided by this one. You have 1.36 mole. Okay. Then you have all this value. So you take the mole fraction first, means total mole is this one plus this one. Total mole this one plus this one, 0.17 plus 1.36. You take how many mole of PVA? You have 0.113. And mole of PVC is 88.7. The purpose here, The purpose here is to find mole fraction of this one, mole fraction of this one. So this is the way you calculate. The strategy is to assume that you have 100 gram, change this into how many mole of this one, right? Example 3, you need to find the mole fraction of PVC and PVA in copolymer having here. Having this molecular weight 10520 gram per mole, degree of polymerization is 160. So this one actually testing you the definition of degree of polymerization. So you write degree of polymerization equal to this one divided by each one of these, right? Divided by monomer of this one, monomer of this one. Okay, molecular weight you already find just now. So fraction of mole between this one and this one is 100%. Again, this is a formula similar to your composite chapter. Okay, so molecular weight of average equal to fraction of VC plus fraction of VA. Okay, and you can convert the VA to VC term. All right, 1 minus VC is the same as this one. Then you substitute lah. Okay. Then you solve simultaneous equation, you get the FVC. Once you get FVC, you know what is FVA. Okay. Example 4 is your homework. Go and read. Then other methods, you also read. This one is condensation. Another one is network. This one also you read. Plastic processing. This one your homework. Go and view this YouTube video. So how you process thermoplastics, really show you like how they produce metal, injection molding, like all this you read. Okay. So read extrusion, blow molding. You blow into the mold. Then you compress molding. Okay, this one you read. Advantages, disadvantages. Okay, transfer molding. Okay, so these are the basic properties of the plastics. And these are the creep fraction properties. Okay, this one also you read. Okay, stress relaxation given by this formula. Stress equal to stress O exponential minus T divided by relaxation time. And the relaxation time will be given by 1 over relaxation time equal to C E minus Q divided by RT. Example 5, your homework. I assume you already know, right? Oh, you're very smart. Example 5 is your homework. Diffusion. Okay, diffusion equation J equal to PM divided by gradient of your permeability coefficient. Okay, so there's another equation for solubility, C divided by T. Okay, the rest you read from the PowerPoint slides. Okay, so I need to highlight this chart because you'll be seeing this one in your final exam. So you need to memorize the PM delta P over delta X. You're using the PM value from this table. Okay, it depends on how you use this one, O2, N2, CO2, HO2. Okay, so it depends on polymer, how in what environment. And I repeat, how you use this J equal to PM delta P delta X. It depends on what environment you put to produce the polymer. For example, the question meant you put under carbon dioxide environment, you read from carbon dioxide column. Okay. So this will be the last slides. Okay. So the last slides. So this is a very important table that you need to memorize, right? So this is what is the uses of this one? We'll use this example. So example is this one. When you work later, or maybe in daily life, you see this carbonate container. So this one, you have a clear plastic bottles to put inside your drinks lah. So this one we are using PET. The fizz pop result is dissolved because inside got CO2, and PET is permeable to CO2. So from permeable means CO2 can come out from the plastic. It can come out. So a 20 ounce bottles of pop has CO2 pressure about 400 kilopascal inside bottle. The CO2 pressure outside is 0.4 kilopascal. So you need to solve this one. A, assume condition is steady states, calculate diffusion flux. Diffusion flux is the J equation of CO2 through the wall of the bottle. B, if the bottle must lose 750 cm cube STP of CO2 before the pop start to taste flat, what is the shelf life of a bottle of the pop? So it gives you the area, 500 cm square, and the wall thickness is so and so. Okay, we solve for A first. So you use diffusion flux J equal to minus PM. Minus means it go outside. Minus means it go outside. J equal to minus PM delta P over dx. So this is the gradient. This is the gradient, P versus. So basically, this is the change of pressure. This is the thickness. Means it go through the plastic here. No, the CO2 is inside. You want to come out. So the pressure difference between the inside outside and the thickness. This one is the thickness. Delta X is the thickness. PM you read from the graph, from the table. So you from the table, you have the PM value. So this one is CO2. So read from here. Then depend on what material. This one is PET. So go and read PET. PET, let me see. I also forget what is the full name. This one, polyethylene terephthalate. This one. This one, So PET, you read here, 0.23. Substitute here. Okay. So it tells you already, inside how many pressure, outside how many pressure. Submit. Okay. So you just substitute inside there. Okay. Only need to be careful on the unit. Just now you read is 0.23, right? But be careful. On top, got 10 power negative 13. This value got 10 power negative 13. So when you substitute, just be careful on the unit. Yeah. Okay. Then inside P2 is inside 400 kilopascal. This is P1, P2. P1, P2. So 400 minus the outside one. Okay, sorry. 400. No, P1, P2. P2 outside. P2 outside. P1 is inside, P2 outside. Because the gradient, the pressure will always go from high to low. So P2 is inside, means the gas coming from P1 to P2, right? The direction of the flow. right? So it high pressure to low pressure ma. So inside one is 400 kilopascal, outside is 0.4 kilopascal from high to low. Yes. P2 is outside. P1 inside, P2 outside. Then X is the thickness of the material, the wall that they need to penetrate. Okay. So you calculate, you'll find one answer. The unit is cm cube STP divided by cm square S. STP is what? STP is standard pressure. Okay. This one is volume. This one is area square per second. So the second question is ask you how many it can last. Okay. So this is what you learn in your fluid mechanics. Q. Oh, heaven. Oh, heaven. Okay. But anyway, flow rate is a Q. Flow rate is V dot equal to JA. What JA? You see this one? This one is J. You multiply by area. Is the penetration per volume. Volume per second. Okay. So if you want to find flow rate, you just take the J multiply by area. So the area is 500. Assume 500. So you multiply by 500. You need to remember this one. Cm cube standard pressure divided by area, cm square. But it will be given in the question. It will be given in the question, just copy only. Okay. So you find the volume that loss per second. So let's say, so it will take 500 time will take for a volume of 750 to escape. So means you have a bottle of 750 cm cube of CO2. How long it will take? So you take this one divided by this one. You take the time. So is how many seconds? It convert to days. So it can, this one it can store for 97 days, about 3 months. The CO2 will become flat. Means all the when you open, you won't have sound. Means it's just open just like normal water. Okay, so the step is standard. Okay, the rest you read. The application of thermoplastics, what are they used for? This one you read. Read a lot. Okay. This one you read just read Just read But application, at least you know, you've seen all these names before. All right. Okay, with this we conclude chapter 10. Later.
No class.
Do you want to have class?